Hey everyone, I'm really excited about this session of Dr. Spotfire. This is a deep dive into how to build an application, a data science application with Spotfire, and it's going to be done with our very own data scientist, Colin Gray. Now, Colin goes into all the details of how to set up controls, how to set up sliders, how to set up Python and data functions, how to use TensorFlow, all to create something that makes your work easier as a data scientist. Now, you might be using Spotfire for specific use cases, and you might know that you can make into an application, not just a dashboard, but this is more of a general use to make your job easier day to day with whatever you're doing as an analyst. So sit back and relax. It's a pretty chill session. He's going to go through a lot of different details. I put the timestamps in the video description so you can skip through just to the points you want, but a lot packed in here. I think it's a great session, and I hope you enjoy.
So I was going to talk today about using Spotfire with Python. So to actually do data science and using things like TensorFlow, which are very popular libraries. One of the things I want to demonstrate is how you can really create an interactive and visual way to build data science models using Python and TensorFlow. And I want to talk a little bit about why that gives you a sort of better way, I think, to actually perform data science. Some of the strong advantages that gives you. And I'm going to build some of the key components in Spotfire and just show you how I put them together and the way we're able to sort of then maximize the impact that they have. So let me just dive in to what we actually mean. So one of the things that I notice in the industry is how much people use Python to do data science. It's a great language for it. But often we stick to the code. You see a lot of Python notebooks, which are really useful tools, or they write it in some other tool, and we keep everything in that sort of Python world. But when we combine Python with visuals and interactive tool like Spotfire, it can bring a whole new life to your data science process. So, and that's something that was starting to be called hyper-converged analytics, where you combine these really powerful interactive analytics tools with data science tools like Python and low-code, no-code tools as well, and even pulling in things like streaming data, so real-time information. So this is something I've been doing for quite a long time in past jobs and past experiences, and it's something that I've seen a big impact. So I just wanted to quickly run over, because I know often when people have used a lot of Python, it can be, and I certainly did this when I was using a lot of R, it can be hard to switch out and do less in code and do more in sort of drag and drop visual tools like Spotfire. So one of the biggest things is it allows a data scientist to focus on the data science rather than the code. When you're doing data science, you really want to be looking at the data and all the models and interacting with that and analyzing the performance, testing new ways, and not actually focusing on writing code. We're actually paid to be data scientists, not coders. So it gives you a more extensive and interactive way of doing that data science, and it really opens up the world there. And by pulling away and putting that data science into a tool that's more visual and interactive, you're actually lowering the barrier of entry. So for instance, I built a tool previously where not all the team of analysts and modelers were strong coders. So I could write some code and then plug that into Spotfire or another tool, and then they could get the benefit of the data science, or maybe even non-data scientists or set of data scientists can use it. And one of the things that you often hear is why people don't want to move away from code is that it reduces the flexibility they have. But actually, I hope to show you it increases how flexible you can be. But one of the big things for me is it actually makes your tools more sustainable. You can be more responsive, and your tools are more reliable because you're not so heavily reliant on code. Every line of code you write can produce an error or be an error point. And as your code gets bigger, it's harder to alter. But when you mix and match that with these tools, with Spotfire, you can be much more responsive to new requests or new data. And it means, it's more sustainable as well. As your code gets older, as you move on, maybe you take a different job or change project, and the other people using your code might struggle to understand it, or the knowledge gets lost. So these things are really important for long-term data science to be sustainable. And I think that's where I hope the demonstration today shows you how that can be improved by reducing the code you need. So only using code, Python for what it's needed for, but using Spotfire for what it's good for. And by having lots of it in Spotfire, it's easier to show a flow of how your data science process worked. And I would hope long term that actually improves the quality of your data science. You know, it allows you to do things like separation of concerns, so building little bit of functions. And once you've got it written once, it's always right. So I've done this in previous jobs and with customers, and it's something that comes up quite a lot. So I'm going to show you an example of this process. So just to summarize, you know, data science could be these steps. You know, you're going from gathering to exploration to cleansing to feature generation and selection and to model exploration right to publishing your model. And this, in the great world, is just a nice linear process, but actually you're often jumping around because you try a model, it doesn't quite work, you go back, you change the data, you cleanse it, you find an issue, you know, and it becomes a very evolutionary and iterative process. So what I'm going to cover today is every block here in green, I'm going to try and cover in a tool. We're going to show a little bit of data exploration gathering, but mainly we're going to show feature selection rather, exploration of models and model optimization using TensorFlow. So let me actually go into the Spotfire tool and give you a preview of what we're going to build. We're going to break down each part of the process into a tab in Spotfire and make it like a workflow that somebody could follow. Now this could be for someone else in your team or someone not even in your team. It could be for yourself. I find doing this, actually I do this for any data science work because it makes my life easier as well. So we're going to build a TensorFlow model where you've got lots of different options on how that model runs in that neural network. We're going to look at correlation analysis and we're going to look at feature selection and how that can be pulled together into a flow. So let me go back to the start of the tool and actually build this up from beginning. So the data I've got in Spotfire here that I've read in, so I just had this in Excel, but it could be from a database or from anywhere. This is a data set of information from lap times from a Formula 1 simulator game that we have at TIBCO. And what happens is people race the laps, it pulls out all this data. So you've got all these, each row is a second of that lap that they raced, and you've got things like the speed they went at, how much they were steering and braking. So you can see there's a lot of columns here, there's a lot of data. And what we want to do is use TensorFlow to try and predict someone's final lap time. So that's the lap time here. So this person did a 94-second lap. We want to predict that at any point during their lap. So I'm going to use that as my test set. So the first thing in Spotfire you want to do is obviously you want to do analysis. So you can see I've created a tab for each of my steps that you saw in this presentation here. So we're actually mimicking that and breaking down our process into the individual steps we want someone to go through or we want to go through ourselves. The most obvious step is just analysis. You know, Spotfire's got its inbuilt analysis where you can use AI suggestions to pull on charts. So I can click on, for instance, X and Z, which are the axes, the coordinates across the track. I could pick on anything like speed, and it'll suggest ways to plot that. And you want to explore that, but we want, again, to give people a nice, easy way of working. So what we can do is create drop-downs that actually change the visualizations that you see. So these are very simple tricks to allow you to start exploring your data sets. So here I've got, as you change the variable in your data, it changes the data on this y-axis and it's plotting it against lap distance, and we're looking at the color to see whether it's a fast or slow lap. So pink's a fast lap, white's slow. And what we're looking at is to see if there's a lot of pinks separated from white, it might be a good variable to predict a lap time from. You can see it's a bit mixed of what variables might work. But you can see it instantly already just by this one simple drop down in a text area. So in Spotfire, you can have text areas where you can create drop downs that you can then use as expressions on the axes. You can very quickly allow people to explore data without needing any code. And here I've got a box plot. But I want to focus on the really interesting data science parts. So that's just pure Spotfire. I've not written any Python yet, but we wanted to get a feel for our data. So let's start by doing the feature selection stage of our process and show how we build that up. So what we want to do is give people a very easy way to create and manipulate data that then works in Python. So if we're going to do feature selection, so this is picking our features that we want to use to predict our time, we want to anticipate and make our tool really flexible. They might change the data, and they might change what model they want to build. So the first thing we do is actually use a text area to give someone options, and that will be sending these information out to Python. So let me just create another text area beside this. I'm just going to create what I've already got here, but just show you how I did this. So in data science, you obviously want to pick something that you want to predict. So we can do that by using a drop-down. So if we create a text area, what we can say is, select target variable. And this is the thing we want to predict. And then you can create a drop-down in Spotfire from the menu up here. What we do is we create a variable. So you give a variable name, it's called a document property in Spotfire, and that will store whatever the person selects from this drop-down. So in this case, we've got selected target. And here we want people to pick from the columns available in our data. So this is our data table. And you can do things like put filters in here. So, data type integer, or real, but I'm just going to let it pick all the columns. And now you can see I've got the same thing that I've got here. Now I can pick what I want to predict. So we start to build that up, and we then want to be able to say, well, I want people to then pick what columns from our data set we want to pass into our feature selection. And again, you can do this very easily from a different type. So we call it list box. And we create another variable and we'll select predictors. And in here, again, it's a column selection, and we want them to pick from the same set. You can specify which columns to use. So if you want to manually pick columns to show in these drop downs, but because we want this to be dynamic for any data set, I'm just going to again show all the columns. And now you can see I've got a column selector. I want it to be a bit bigger, so I can right click and format it and specify a size. I want it to be 200 in size. And so we're starting to build up ways of actually allowing someone to configure and run Python code in feature selection. So the last thing we want to do is just create a training and test split as well. So when you do feature selection and modeling, you want to have your data split into train for the model and then test to actually test the performance of your model. So again, what I did here was create another input into a text area where someone can type in the percentage they want to create their training and test split. So again, that was just from adding a selection here where I could say, train/test split. And I can put an input box into here. So to build up these very visual and controlled and dynamic data science, you're going to use text areas with inputs a lot. So here I can see training split, it's a number, and I want somebody to be able to enter that. And if we save that, now you can see the same thing here that I've got across here. So let's actually use these and do some Python and a little bit of calculated columns of Spotfire. So as I said at the start, I want to only use Python for the parts I need Python for and keep everything else in Spotfire so it's nice and simple because people can come in and edit it. So I can actually create a random test and train split of data in Spotfire without the need for code. Because Spotfire's got extensive calculated columns, so what I could do is column properties, and I can pick my Melbourne Labs data table, and I can insert a calculated column. So if I want to create a random test set, for instance, you can use the command rand, which just generates a random number between 0 and 1, and just give it a seed. So I can just call this random number. Just put 0 to 1. What that does is it's actually created a column on our data set. If we just go back to our data set, where you can see at the end of it, this random number that we just generated, and you see it's between 0 and 1. So you can do a very simple thing that if somebody types in 80, we can actually select anything below 0.8, i.e. the first 80% of your data, and use that as our train and test split. So again, you can do that through a calculated column, and I can say, okay, if we can do a simple expression here of an if statement, so we can say if that random number we generated is less than or equal to, and pick your training split property and hit insert properties here, you can call that train. If not, we'll call it test. So by doing this, and we'll just call this, you know, by doing this, we're creating a column in Spotfire that's actually generated a random train and test split. So for instance, if we now plot all the number of columns, the number of rows rather, that are train and test, and we change this, if I change that to 60, you'll see that now we've got 60% as our train randomly selected and 40% as our test. If I put it back to 80. And that's working because in this column, as I showed you just before, this train test split is using that document property we created here in the text area. So whatever you type in here gets inserted into that if statement. So we've already instantly created a random sampling selection that we'll use throughout this process, but we've given the user or yourself the control of how much you want to split your data very easily. So now we want to actually write some Python and pass our train and test split to it. So what you do is you use data functions. Now I'm not going to cover data functions in too much detail, the background of them. In previous Dr. Spotfire sessions, there've been the last one, dive into Python data function and Python and Spotfire X on our YouTube channel. If you just search for Dr. Spotfire on YouTube, they've got the in-depth details of how to actually build data functions from scratch. But for the sake of time, I'm just going to jump in and show pre-built data functions and how we configure them. So when you get a data function and you create it after you've registered it, you can edit the script. And so in Python, you just start writing pure Python like you would in a notebook, for instance. So we've got our imports up here. And then the first thing we're going to do is you'll see that we're splitting our model data on that column we made. So I've made the column called data usage, which had my train and test split. And it's just filtering to where that's equal to train. I'm then dropping that column because I don't need it. And then we're going to just set X, which is our train data. And then we're going to take out the target, which is our Y data. And Python makes it very easy to generate feature selection just using the sklearn package. And we can do it through random forests or decision trees. So in this one, I'm going to use a decision tree regressor. And I'm just going to fit my model, which will use the X data to predict the Y. In data functions, how does Python know to use these variable names? Where does model data come from? Well, it's because you can set that as an input variable. And if you look at that input variable, it's we've got something called model data, and it's of type table. So that means in Spotfire, we can assign a table to that variable. And when you refer to it in Python, it uses that name of the data you passed in. So we can actually, that's crucial to how we do this, because we'll build up lots of more features into this and make a really in-depth data science model. So what we're going to do is we're going to pass in our model data, which is just the raw data you've seen before, and then we're going to pass in a target column name. So the target column name tells the Python what are we trying to predict and what are we assessing the feature selection for in terms of importance. So that's going to come all from this so that we never have to edit our code once this is up and running. So the idea is you write very succinct small functions and then you never really need to edit them because you control it all from this visual front end. Therefore, you know, protecting people from ever having to edit code if they don't need to. So once you've written your script, you can edit the parameters and tell it how we're going to pass data. So the model data, what you can do is you can just say columns, and we could just pass all our columns if we just put star. You could manually select columns, but I would avoid this because we want it to be dynamic. So doing stars is possibly easier. But what I've actually done here is use an expression. So what you can do in an expression is you can actually take the variables selected in your dropdown, which was our selected predictors. So if I just delete that and hit insert properties, it builds up a string that just says everything I've selected in here, pull that out. And then what I can do is I then added manually the selected target. So I'm actually saying also give me the selected target and this data uses column, which was telling me my train and test. And then if I want to tell it what the target was, so that's from this dropdown, you just tell Spotfire to pass to Python the document property storing that variable, and here you can see it's time to complete lab. So these then get inserted into the Python code, all the data in the target, and then the output is the feature importance of the decision tree. And what we're going to do is create a data table. So we can click determine importance, and now it's running that Python code. And you can see that change slightly. I'm just going to delete my example here so you can see it better. But I can now make this very dynamic. I can go in and I can select a whole new set of variables. Say I only knew these ones were available. So I wanted to select, ERS down to surface type columns here. I want to pick steer, brake, gear throttle speed, engine RPM, and hit determine importance. And now it's using the cart decision tree model to determine importance. And here you can see it's completely changed. I might want to change my split and again run determine importance. So you can see how fast you can now run multiple parts of your data science process without ever having to touch code. You could even build it so that you could determine importance over different things in multiple models. So what we could do is actually extend this and do a decision, do importance over different models. So for instance, in this example here, what I've done is I've actually built a feature importance using cart and the random forest. And I've expanded my information here. So if you now look at the Python script and the feature importance, the only change here is I'm now running a random forest regressor as well as a decision tree. And then I'm returning two results, so the decision tree results in a random forest. So you can see I've now got two outputs instead of one. But the interesting thing here is you can specify variables to pass to the random forest model. So instead of just hard coding this to 50 and 15 or something, by making them variables that you can pass in from Spotfire, so these are now input variables like the target and model data, you can now make this again really dynamic. So these input boxes here are assigned to those variables I just showed you, and they will affect the random forest tree. So I can say number of trees 40 with a depth of 20, and now determine importance. And now it's running two different feature selections that we can compare and contrast. So it just takes a second to run through that because I put more columns in. So we can start doing that process. We've determined our importance. And what we want to do is make this very visual. So what we can do is say, well, let's mark data and only use the columns we've picked from marking here to actually take forward the model. So if I just mark from, say, these 4 or 5 up, I can then start using that for my next stage, which is my correlation analysis. So if I calculate correlation, it's just going to use the marked items instead of all the data. So here you can see it's only used the columns here for the correlation. And again, this is the same as what we showed before with determine feature. It's using a very simple Python function, which is very small. But again, we've given the user control, for instance, to use different methods of correlation. So now what we've done is we've got a column correlation script. And what you'll be able to see in here is it's just a very simple script again. And one of the main things we're passing in is a correlation method. But one of the key things is how we parameterize this is in terms of the selected features. What we said was only use the marked rows. And that means that when someone picks features from here, it automatically only sends those rows. So if we just pick, say, the top 3 and run a correlation analysis, you'll see it's dropped down to just showing the correlation between these top 3. So that gives you this way of jumping back and forward in an iterative way. So if I pick a few more variables, go to correlation analysis and calculate it, what I might want to do is remove some of the highly correlated variables. And all I did here was use the data that came back from Python to plot this heat map, purple and blue showing positive and negative correlations. So I might want to strip out some of these before I actually do my model. So for instance, I could go back here and say, right, let's not use ERS deployed and unselected because it's too related to lap distance. So the very final stage is doing the TensorFlow model. And again, it's the exact same principle. Once we're here, we just have a data function. And what I've done is, again, you've built out lots of options in a text area. So these are just simple text areas where you've got drop downs and text box that people can enter into things. And then for our data function, we've got this Keras model here. So again, we're passing it the train and test, so the column we created in Spotfire to split our data into train and test. We've passed in the target again, which has come from our dropdown as before with feature selection. And then what we're doing is we're using the features selected. So we're passing in a column as an input, which is the columns that were selected from that visual here that you can see. And that means we can just concentrate on those features selected. And then the rest of the code is actually just typical Keras or TensorFlow models where we're building up a network and we're setting up the different layers in that neural network. But again, we can make this completely dynamic. So normally you would see input layers set to something like 64 and maybe the activation hard-coded in. And you can see hard-coded in the callbacks, etc. here. But what you can do again, Spotfire, is completely make that tunable by the person who's doing this by creating these controls again. So in this example, in my Keras model, I'm passing in not only the data and the target as normal, I'm also passing in what features were selected based upon the marking as before, but I'm passing how many epochs I want to run, how many hidden layers at the start, my activation function. And again, these all just get passed into your Python code inside your script. So the names match up from here to the script. So this allows you to do things like change the epochs. So I could do a very simple model, 20 epochs, 32 layers, and we'll keep my training split. And here you can see I've got 11 features selected and build a model. So what this button that I've been using each time here in the build model, it's a very simple way of adding a button to click in Spotfire. What you can do in a text area is add an action control. So for instance, any data function, you can simply click on this, insert action control, and say run the model. And then you can click data function and say what data function you want to run. So now I've got another button that does the exact same as that button. So it's all about creating these visual inputs, and here you can see my model ran. And when you run these data functions, they return the data, so it's returning the residuals, etc. So now I can really explore my model without ever having to worry about code. I can up the epochs, the initial layers. I could try a different activation function and a different optimizer. So here I've got a R-squared of 0.95. Here's a summary of the residuals as well. So this is the residuals that came out of the model, and I can build the model. So all I needed back from my Keras TensorFlow model was the actual predictions. In Spotfire, I can calculate the residuals using calculated columns. So here you can see I've just taken the prediction off of the thing we're trying to predict. And it all becomes very interactive. I can jump between all these steps and keep producing lots of models. You could expand this and actually do hyperparameter optimization by looping over some of these and passing back multiple models. But this gives you a real power to let people explore without ever having to worry about code. The nice thing as well, you can then take it further and look at model assessment. But one of the great things about Spotfire is because you've got a data canvas, you can then join the model predictions to your original data. So even though we only used 11 of the columns of our data set, we might want to compare it to all the data. And in Spotfire's data canvas, what you can do is copy data from your tool. So I can take a copy of my original data, join it to my Keras predictions that came back from Python, and that's what I've done here. So I've got my original data, I've then done a join, a column join, so you can see that here. I've joined on the ID column that matches the right rows between my original data and my predictions. And then I've added the prediction that came back from Python and the residuals I calculated. And that means I can do things like put your data into context, which is really important. It's okay to look at things like R-squared, but they only give an initial impression of how good your model is. You really want to put it in the context of your use case. In this case, it's our laps. So here we can see in the blue line the actual time to complete the lap for each individual lap someone raced, and then the yellows showing our residuals, how far away from the truth. And you can scroll through these and see, well, our R-squared is good, but some of the models you can see at the start of the lap, they don't perform as well. Our residuals are much worse. We can see interesting laps like here, or something like here. Let's just have a look. Here, where the residuals are way off, and then suddenly the model changes. So we can analyze that. And in this little map here, this is showing the person's position on the track. And here you can see they actually skidded and spun off on the track. So our model's actually picking that up. So it's really important to use the visual analytics to analyze and put it into context, because the model might look poor before now, but actually it's predicting really well because the driver made a mistake and it anticipated that and reacted. And all that becomes very apparent doing this sort of visual workflow process, calling Spotfire with Python, breaking it into your steps, and then assessing it at the end. So that was a sort of run through how a technique I've used many times with my own work and lots of customers. And I think it really opens up your use case. You can now give this to someone else. They can run it without worrying about your code, or you can publish it in the web. And it also makes it easier to show off to business people, decision makers, and show them how it works, or audit what you've done without people having to understand complex code or excessive amount of code. So I'll stop there. I'll just mention that, you know, there are other ways to do this in low code. It's worth checking out Python data functions documentation as well for Spotfire. If you're interested in the use case I just showed you, there's actually a webinar that I do talking about this in more detail, where I go heavily into Formula One simulator lap predictions, showing you things like this and how you use Spotfire. Again, it's all calling out to things like Python and TIBCO data science. So that's available for you, for anyone to watch if you want to learn a bit more about that.
Cool, awesome. So Colin, there are few questions, but I will take just one because of time. I know this answer will be too big, but how you maintain those model files?
Yeah, so that's a good question. There's multiple ways to maintain the model files. So one of the things you will see in the scripts that I'll post in the community is what I've done here is I've used a callback to actually save the best model, because when Keras or TensorFlow runs, what it returns by default is the last model, not the best. So this code here creates a model checkpoint, and what it does is it writes that model out to a file. So depending on your environment and where you're running, you can write and read models back. So you could write out a model in code and then read it back somewhere. There's one way to do it. You could obviously deploy or send that to a service, for instance, by calling a web service. But one of the tips that they have on the Python documentation is to use models from a previous data function. So there is a method where you can return a model using this pickle package, and it returns a binary object. So what you can do is make that an output of your data function, so it gets saved into Spotfire as a binary document property. And then you can pass that back into a new data function and use that model. So if you have published a model in this tool and you want to just score some new data, you can do it via that without having to retrain your Keras model. So there's multiple ways to do it, but those are the sort of two, I think, obvious or quicker ones.